In this video, we're going to focus on one of the key points that comes up when looking at relationships between coordinates in a diagram or in a system, and that is the property of collinearity. What we're going to look at is defining what collinearity means, thinking about how we'd approach a problem involving it and what steps we generally would be able to do, and then looking at proving whether points are or are not collinear to each other. First thing we need to do though is know what the word means. So what does the word collinearity mean? The word collinearity refers to when points are on the same line. So it's when several points are on the same line. So i.e. if I had 3 points A, B and C, they would be collinear if they were on the same line. So if they're on the same line. So if I plotted them, they would be a point A, they would be my point B, and they would be my point C. If I was able to do a straight line going between all three of them like that, they would be collinear. However, if I had, let's say, a point A there, a point B, and then a point C here, I couldn't do a single straight line that joined all three of them up in one go. It would have to take a break or a bend in the middle. So what that means is these 3 points are not collinear. So these ones are not, these ones are. What we're going to look at is focusing on how to prove they're collinear. So how do we make sure that we can say A, B and C are collinear or A, B and C are not collinear given the information in our system? And it's actually quite a straightforward set of steps. So imagine our ultimate question is we wanted to see if 3 points were collinear and lay on the same line. So imagine I wanted to answer the question if the points A, B and C were collinear. What would I do to answer that? Well, there's a couple of set steps. First thing we do to test it is we calculate the gradient between the first 2 points. So in this case, we'd say we want the gradient between A and B. Our second case would then be we calculate the gradient of either A to C or B to C. Now I'm saying there's or because there's something you'll notice that regardless of which of these two you do, there is a part they share from the first one. So the gradient of A to C shares the start point A. Gradient from B to C shares the end point B. And this is a key thing. They must share a point. Okay, they must share a point with the first part. Because what happens is then at this point, what we can say is if the gradient of 1, so if the gradient from AB matches our gradient from part 2, they are collinear. Okay, they've got the same gradient between them, plus there is a common point between them, i.e. they share a point. So that would be one of the cases where you've got your 3 points, A, B and C, all joined up with a straight line. That would be a collinear one when it's like that. If they don't, even if it's off just slightly, we'd have to change into a different straight line. They are not, because these two gradients are not the same. This is how we prove if 3 points are collinear or not. So, a couple of examples of this. So first one, imagine I give you 3 points. I'm going to have a point Q, which is at -6, -1. I'm going to give you a second point Q at 0, 2. And I'm going to give you a third point R at 8, 6. And the ultimate question is, are they collinear? Okay, that is our ultimate goal. So the first thing you do, step 1, start your first 2 points. In this case, I would start by saying, what is the gradient of P to Q? So in this case, I would do 2, take away -1, over 0, take away -6. 2 minus -1 gives you 3, 0 minus -6 gives you 6. So my gradient's a half. Now the second one is I can then choose to do the gradient of either other portion of the line. So I can either do gradient from P to Q and match that up with the gradient from P to R, or take my gradient from P to Q and match it up with the gradient from Q to R. Either way, it doesn't matter which section of the line you use, as long as there's a common point. So let's start by doing the gradient from P to R. So we'll take the very end point. So we'll do the gradient from here to here. I do 6 take away negative 1 over 8 take away negative 6. 6 minus minus 1 gives you 7 over 8 minus minus 6 gives you 14. So my gradient there is a half. Great, if I'd chosen these 2 points, it would work, the gradients match. But would it have worked the other way? Well, let's see. Imagine I then do the gradient from Q to R. In this case, my gradient would be 6 take away 2 over 8 take away 0. That would end up giving me 4 over 8, which is a half. So my gradient here matches either of these 2 gradients that I choose. The key point is that a common point regardless of which of the 2 of them I choose. Now this is where our key part of communication within mathematics comes in, because great, we've done the work, we now have to be able to explain our answer. So whatever one you pick, we have to make sure of it. So we'd say, so therefore our gradient from P to Q equals our gradient from P to R equals our gradient from Q to R, and whatever are the common points you had, so if I chose this one here at the top, I'd say, and P was a common point. If I chose my PQ and my QR, and Q was a common point, so I'll stick with the first one, and P was a common point, P, Q, and R are collinear. We have to clearly state these sorts of things when we're working in maths. Okay, communication is key to gaining marks in questions like this. There's no point in just doing it, getting a bunch of numbers and saying, yay, matching gradients. We have to be able to explain our work. And this is how we do it. So the gradient from P to Q equals a gradient from P to R, and P was a common point, therefore P, Q, and R are collinear. Or gradient from P to Q equals Q to R, and Q was a common point, therefore P, Q, and R are collinear. We have to be able to explain it correctly and openly, regardless of which way it is. So that's proven if a point's collinear. However, what we also may get is told points are collinear, fill in the gaps. So for example, if I had a point A at 1, negative 1, a point B at negative 1, comma k, so some generic value k, and point C at 5, 7. Now imagine if I told you that they are collinear. So we know they're collinear already. Ultimate goal is to find k. We have to utilize this. Now we know that since they're collinear, the gradient of the whole line, because these 2 points are totally known, so we know the gradient of the whole line from A to C equals the gradient of this first part where we share the common point of A, but we include our unknown part as well, equals the gradient from A to B. What this will allow me to do is set up an equation which I can then use to solve and find my missing part. So my gradient of A to B is given by this, so you get k take away negative 1 over negative 1 take away 1 equals the gradient from A to C, 7 take away negative 1 over 5 take away 1. And now it's a case of solving it via algebra and getting an answer. K minus minus 1 gives you k plus 1 over minus 1 is take away 2. 7 minus minus 1 is 8 over 5 minus 1 is 4. 8 over 4 is 2. So it allows me to set up a nice basic equation of k plus 1 over negative 2 is 2. Get rid of the bottom there by taking it up. I know then that k plus 1 equals negative 4. K equals negative 5. There we go. We've found our last part. We've found our k. I could then, for completeness, tell them that my point B is actually located at negative 1, comma negative 5. I've got the ultimate goal I want. This property of collinearity is very, very good. It's very, very important, and it's very, very easy to utilize in scenarios like this where we're utilizing the properties of a straight line. The key thing to remember, gradients and intersections have to be the same. We have to share a common point between them. That's vital. And when it comes to our explanation, we have to explain it properly, clearly, and accurately.